is look over the ticket to lab and see if you guys have the same answers as I do. Okay, and if you do a different way than dimensional analysis, when you get into the computer lab today, you can go to ATI and choose the other way that you do it. I don't really know how to do it those other ways. So, you know, that's how it goes. So we had the example there. So on number 2, if we were doing this in dimensional analysis, the thing about dimensional analysis is that every math problem can be done that way, right? When you see this little handout I gave you, it says dimensional analysis. What is dimensional analysis? It is a simple mathematical process. It's in an equation format. The equations are set up and solved in fraction multiplication format according to the units of measurement. Advantages of it, it's simple, it's organized, the problems can be set up in one step. It allows the nurse to easily identify incorrect setup before calculations are carried out, a key factor in accuracy and efficiency. That just means you know if it's set up wrong because your units they won't be able to cross out, or they'll be flip-flopped and you'll know you have some numbers on the wrong way. An incorrect answer resulting from incorrect setup can be immediately identified. And then it shows the 3 elements of a dimensional analysis equation, which is desired answer units, the given quantity and its units to convert, and then conversion factors. So, and then it goes to this setup right there. Identify the dose ordered. That's the beginning of the point of the calculation. Identify the ending point, and then use conversions in the middle to get there. Okay? Don't freak out. So if we're looking at number 2 there, it says ordered 35 milligrams of Demerol IV, and then it says what we have on hand, 50 milligrams per ml. This is a pretty simple one to do, but we started out like that. So what we have to start with is that we want 35 milligrams, right? You're doing dimensional analysis. And then what we have on hand is 50 milligrams per ml. And that's what we're looking for, milliliters, right? We see that out to the side. So we know we cancel out our milligrams. Then all we have to do is divide 35 by 50 to get what? 0.7, round to the nearest tenth. And it's going to tell you on the ATI exam, round to the nearest tenth, round to the nearest whole number. I think those are the 2 main ones that it says. It may say hundredth, I don't know, but usually it's to the tenth or to the whole number. So did everybody get 0.7 mLs on that one? Awesome. So then number 4, it says there is 660 milliliters of D5W infusing at 28 drops per minute. The drop factor is 20 drops per ml. How many hours will it take for this IV to complete? Round to the nearest whole number. Okay, so if you do it in dimensional analysis, we started with 660 mLs. Was the first thing we had. Now you're going to have a big long line of stuff. The next thing I wrote down that we know is 20 drops per ml. Then what else do we know? 28 drops a minute, correct? So where does the 28 should go on the bottom? Y'all see that, right? 28 drops per minute. What are we trying to get to? Hours. So we need a conversion. So right here we put what? 60 minutes over 1 hour. Okay? Then we cancel out our, and we're left with hours. So we know we're right. Okay? I had a student last year that tried to do dimensional analysis without putting the labels, and I'm like, you can't do that. That's very confusing. So you have to do it all. So you multiply that out, and you got what? I got 13,200, right? Over 1680, which gave us what? 7.85. And we asked to round to the whole number, right? So her IV is going to be done in about 8 hours. Did everybody get 8 hours? Who did it a different way but came up with 8 hours? About 6 of y'all, so about half. Okay. Y'all, I don't know what the other way is called.
Well, there's two other ways. There's ratio proportion.
Per minute. Okay. And so on number 6, we're going to ask y'all to figure out drops per minute. So it says you need to give 250 milliliters over 2 hours. The drop factor is 10 drops per ml. How many drops per minute should you administer? Round to the nearest whole number. So we know we start with 250 mLs over 2 hours. And then we know 10 drops per ml. Okay. Are we looking for drops per hour? So we have to have a conversion, right? 1 hour, 60 minutes. And then we can get rid of those hours and we're left with drops per minute. So we know we're correct. So when you multiply that out, you get 2,500 over 120, which I got 20.83. Is that what y'all got? And then I rounded it up to 21 drops per minute. Did everybody get that? Awesome. Okay, number 7, y'all saw that. And then you saw that little thing, remember 1 teaspoon is 5 mLs. Now this one's pretty easy. I mean, usually the tablet ones that you guys will see are pretty easy, but I just wanted to show you that even those can be done in dimensional analysis. If you get in there and you're thinking, oh my gosh, I don't even, I missed the last 4, I think, and now I have a tablet one and I don't know how to do that either. It can all be done in dimensional analysis. So it says we have 325 milligrams that we want to give. And it says that aspirin comes in 65 milligrams per tablet. Just mark out your milligrams. We divide that out. This seems unrealistic, so don't. But you're going to give them 5 tablets, right? At 65 each. Okay. Everybody got that one? Awesome. Okay. When we're saying a nurse is preparing to administer ceftriaxone 2 grams by intermediate IV bolus every 24 hours. Available is this injection 2 grams in dextrose 50 mLs to infuse over 30 minutes. The nurse should set the pump to deliver how many mLs an hour. So that's got a lot going on right in there. When you have these problems, sometimes you have too many numbers in there and some of them you don't need. Okay, so don't get confused by what you don't need. We know we have, when you start reading that, we know we have, we're going to give, it says what it's in. It tells you that you have 2 grams that you want to give, but then it tells you, hey, we have 2 grams, and it's already in this solution, and it's 50 mLs in a 50 ml solution. So you can kind of forget the 2 grams because you already see that it matches up, right? Does that make sense? So I actually started with 50 mLs, and I know that I want to infuse it over 30 minutes, right? So this was pretty easy after you started reading it and ignored all the numbers. The 24 hours, you don't need to really know that, right? And then all I had to do was do the 60 minutes over 1 hour, which I got 3,000 over 30. Did y'all all get 100 mLs?
Yeah.
Okay. So we put that example so that you know, when you see there's a lot of numbers going on, sometimes you can ignore those numbers, right? You could have put the 2 grams in there and shown that you also had 2 grams in the other, but really when you're reading it, you know that it matches up and you can kind of forget that. It makes it easier. Okay?
I have a quick question about
Big one, right? So it says drug AB. See, it doesn't, and then a lot of people get, it doesn't really matter what you're given. If you can pronounce it, if you know what it is, it doesn't matter. So this is drug AB, 8 milligrams per kilogram, PO, 3 times a day. And what we have is this drug available in 0.75 grams per 10 mLs in a 50 ml bottle. And we have their weight. Okay, so we have something in that problem that's unneeded. What is it that we don't really care about? Yeah, the 50 ml bottle. Okay, that's fine. It's in the bottle. We don't care. What about, do we care about the 3 times a day? Not really, because, not right now, but when we get into PD, we will, because it may say, you know, not to confuse you, but it may say something like, we're going to give this dose in 24 hours in 3 divided doses. Well, then we know that after we figure that out, we may have to divide it by 3 or put it into our additional analysis. But you guys are correct. For now, that doesn't matter. So the first thing I started with, and like Ms. Gabart said, I mean, you know, you want to end in mLs over here, right? That's pretty. Whatever. Okay, so the first thing I started with is 8 milligrams per kilogram. The next thing I wrote was that we're going to give, we know that there's a supply of 0.75 grams per ml. And you guys may have this, your numbers different, and that's okay. Then I just wanted to go ahead and get rid of my grams because I was afraid I had it in the wrong slide. Milligrams. The other thing that I know is that this patient, I'm dealing in kilograms, and I don't know that yet, right? Because all I know is that he weighs 124 pounds. Okay, so at this point, if I thought, you know, I wanted to see where I am, I'm done with my milligrams. Got my grams. I know I'm looking for mLs, and I have kilograms and pounds, so I need another conversion. And you guys know that 1 kilogram has 2.2 pounds. So now I can get rid of my pounds. And I'm getting rid of my kilograms. And I have 1 left, milliliters, which is what I was looking for, right? So you know it's set up correctly. Don't forget, you know, you're going to have to memorize these conversions. And sometimes people get this one confused. I always tell them, hey, we would all like to say our weight in kilograms, right? Because it'd be, yeah, a lot smaller. So if somebody asks you, you're like, oh, I weigh, 40 kilograms. Thanks for asking. So try to keep those right. So then at the end, you would have, I have 9,920. Is that what y'all have? Over 1650 equals 6.01 or 6 mLs. Is that what you guys had?
Yeah.
Awesome.
I got that number. I got the answer. I didn't do it like that.
It's okay.
Yeah, I didn't either. I guess I did long route, cause I was.
Hours. I mean, that one doesn't require anything, right? Sorry, those zeros. 1,000 mLs over 8 hours. We're looking for mLs per hour. All we got to do is divide, and we got what?
125.
125. Simple. mLs per hour. That made sense. That was easy. And the last one on your take-home says, the nurse is preparing to administer sodium chloride 1.5 liters to infuse over 4 hours. The drop factor of the manual IV tubing is 20 drops per ml. The nurse should set the IV infusion to deliver how many drops per minute. So I don't know if we've done a drops per minute yet. So we have 1.5 mLs. We know we want to give it over 4 hours.
It's liters.
Sorry.
It's gonna be tiny drops.
That's when you would know something's not right. 1.5 liters over 4 hours. 20 drops per ml.
Sorry.
1,000 mLs over 1 liter. And an hour over 60 minutes. And then you just start marking it out. Liter. Drops per minute. And it was a big number, right? But it's okay. 30,000 over 240. It's also 125. Is that what y'all got? Drops